So this lesson is going to be about pH and pOH. We already know about concentration. We've talked about the H plus concentration and the hydroxide concentration and what that has to do with being an acid or base. Just to recap on that, a hydrogen ion concentration of greater than 1 times 10 to the negative 7 moles per liter is going to be an acid, and a hydrogen ion concentration less than that is going to be a base. The opposite is true for hydroxide ion concentration. So typically when we're talking about acids and bases, we're talking about very, very small amounts of hydrogen ions or hydroxide ions. Unless of course it's an extremely concentrated acid or base, but typically we don't work with those in the lab. That might be how we get the acid or base, but then we're going to usually dilute it down to something that is something that we can use for most experiments that we do. So because it is such a small concentration of hydrogen ions or hydroxide ions, we've developed this pH or pOH scale. Now I know that this isn't the first time you've heard about the pH or pOH scale. This typically, when I'm in a classroom, is when I would ask the students, tell me what you know about the pH and pOH scale. So right now, quickly, write down, pause this video, and tell me what you know about the pH and the pOH, or well, I should just leave it at the pH scale. Go. Okay. Now, I really want to know how many of you, but there's no way for me to, under these circumstances, I want to know how many of you put that the pH scale goes from 1 to 14. That is incorrect. This picture, I put this here so we could go ahead and get rid of this misconception. The pH can be above 14. It can even be below 0. For extremely concentrated acids, it would be below 0, and extremely concentrated bases, pH would be above 14. So it is possible. Now, pOH is the same thing, but just in reference to the hydroxide ions. pH or pOH stands for potential of hydrogen ions or potential of hydroxide ions. Okay, so basically this lesson is all about the calculations with pH. So a lot of you are seeing this slide right now and you're like, oh my gosh, why are we doing more math? I didn't take this class to do math. I took this class to do science. Well, guess what? It's chemistry. And we do lots of math in here. But this is really, really basic here. So to find pH, we take the negative log of the hydrogen ion concentration. Now, this is log base 10. I didn't write it here, but it should be understood to be log base 10 if it's not written. So this is negative log hydrogen ion concentration. To find the hydrogen ion concentration, we're going to do the opposite of that. We're going to take the antilog of the pH. Now, you may not have heard it being referred to as the antilog, but it is, in fact, the antilog. On most calculators, the antilog button is just second or shift log. On this calculator that I have here, I would hit shift, and I would hit the log button, and it would give me this 10 to the power of something. The only extra thing that you have to add in there when you're finding the antilog is a negative sign before you put in the pH. So pOH, same exact equations. For pOH, we would find the negative log of the hydroxide ion concentration. Or to find the hydroxide ion concentration from pOH, we would take the antilog of the pOH, or 10 to the negative pOH. Now, if you haven't gotten a chance to copy all those down, I will give you a slide here in a minute where you can copy them all down. Or you can pause the video, go back and copy them out right now, because we do need them for these example problems here. So what if I needed to calculate the pH if the hydrogen ion concentration was 1 times 10 to the negative 6? I would simply take the negative log of the hydrogen ion concentration, which is 1 times 10 to the negative 6, subbing that in, we get negative log 1 times 10 to the negative 6, and it equals 6. Now, if this number right here is exactly 1, and this is a negative something, then your pH is going to be whatever this positive integer would be here, as you see here. But it's not always that simple. If this is not 1, then you're not going to be able to do this calculation is easily in your head, and you're gonna need a calculator. What is the hydroxide ion concentration if the pOH is 4.6? So here I'm given the pOH, and I need to find the hydroxide ion concentration. So this is the opposite of what we just did, but with OH and pOH. So for the hydroxide ion concentration, I would find the antilog of the pOH, which is 10 to the negative pOH, subbing in this 4.6 here, 10 to the negative 4.6. All right. And I didn't actually write the answer in this slide, so let me go ahead and do this calculation really quick for us. Why not show you? Shift log negative sign 4.6 equals. And I get 2.5 times 10 to the negative 5. Now, I'm not going to go over sig figs in this particular lesson. I'm going to do a separate video on how to do sig figs with logarithms because it's just a little bit more complicated. And if you're curious about how to do sig figs with logarithms, then you can watch that video to figure it out. I want to go ahead and review whether each one of these problems is talking about an acid or a base. Just because we're talking about the hydrogen ion concentration or the hydroxide ion concentration doesn't necessarily mean that it's an acidic solution or a basic solution, respectively. So in number 1, would this be an acid or a base? There's a few ways to look at this. So if the hydrogen ion concentration is 1 times 10 to the negative 6, then this solution is definitely going to be an acid. In number 2, we're looking at the pOH. pOH is 4.6. So something that we'll learn about in the coming slides is if the pH is below 7, then it's an acid. If it's above 7, it's a base. And the opposite is true for pOH. So since the pOH is below 7 in number 2, this is in fact a base. Okay, I actually paused this video to update this slide right here and just to put the answer in for this particular problem. After we use our rules for sig figs, we would actually get 3 times 10 to the negative 5. And again, I'm not going to go over that right now, but I'll make a separate video, a short video that talks about significant figures with logarithms. So this is a chart that would be very important for you. So I would go ahead and pause this video and copy this chart down. This is just talking about pH and pOH and what it has to do with acidic, basic, or neutral solutions. So we see here, like I mentioned before, that pH is less than 7 for acidic solutions and greater than 7 for basic. pOH is greater than 7 for acidic solutions and less than 7 for basic solutions. And pH and pOH are going to be equal to 7 for neutral solutions. And again, all of this is true at 25 degrees Celsius as mentioned in the previous video. All right, checkpoint number 1. I want you to pause the video, and I want you to get your piece of paper, pencil, and calculator out, and I want you to do these 2 problems. Okay. So hopefully you had enough time to do those 2 problems. You're going to turn those into the teacher, whichever way they tell you to. So let's talk a little bit more about pH and pOH. We're going to add to this list of equations that we're making here, formulas that we're making to solve these problems. In the previous lesson, we learned that hydrogen ion concentration, that the product of the hydrogen ion concentration and hydroxide ion concentration is equal to 1 times 10 to the negative 14. If we take the negative log of both sides, which includes 1 times 10 to the negative 14, we're going to get that the pH plus the pOH is equal to 14. So this is another formula that you're going to need to add to this long list that I have summarized for you here. So I would go ahead and copy these down. Pause the video and copy these down. We're going to use them on the next slide. Okay, what I've created here is what I like to call a pH square. Now you can get different versions of this online if you look, but this is just one that I've made and students have found useful in the past. So what I want you to do is I want you to pause this video one more time. You have that list from the previous slide, and I want you to take all 6 of those and pick the correct square for each one of these, or I should say rectangle, yellow rectangle for each one of these to go in. Okay, so hopefully you had enough time to do that. If you didn't, pause the video and do it. And, this actually reminded me. I thought of a good joke to tell last time. My students said that they were really missing the jokes through this whole virus outbreak, which is why I'm even starting to make these videos. But if you have a basic solution, the hydroxide ion concentration is greater than 1 times 10 to the negative 7. Or you could talk about what the pH is or something like that. And so if you're really mad at somebody, you can just be like, oh, you're so basic. You're so greater hydroxide ion concentration than 1 times 10 to the negative 7. Maybe a little too much. Your pH is greater than 7. Maybe that's a little less. Well, at any rate, my kids wanted some jokes. There you go. Forgot that one from the last one, but there you go. So, did you get this? This is what you got? Yes, I drew all of this. Enjoying this new computer. So if you didn't get this, pause the video and fix this, because you're going to need this, or you could need it. If you don't need this, don't use it, like I tell my students all the time. These are tricks and trades that I've learned over the years. If it works for you, great. If it doesn't, fine. I don't care what works for you. Just find something that does work. So you might be wondering why I look completely different right now. That's because I made a minor mistake in example problem 1, and I'm here to correct it. So the purpose of this square, just to be clear, is to go from one item to another, but it's also to be able to spot the route that we could take. So, for example, if I'm given pH and I want to find the hydroxide ion concentration down here in the bottom right, I could go one of 2 ways. I could go across the top and down, or I could go find the pH to the pOH and then the hydroxide ion concentration. So in example problem number 1, we have a solution of NaOH that has a concentration of 0.043 molar. Now, this is the concentration of NaOH, but it's also the concentration of the hydroxide ions because there's 1 mole of NaOH for every 1 mole of hydroxide ions in NaOH. So if the concentration of sodium hydroxide is 0.043, then the concentration of hydroxide is also 0.043. So we can take 0.043 and we can sub it into the negative log of hydroxide ion concentration right here. Negative log 0.043 right here, and we're going to get 1.37. Then we're going to take the pH plus pOH equals 14, this equation. We're going to rearrange it. We're going to get pH equals 14 minus pOH. So then 14 minus 1.37 is equal to 12.63, and that is the pH of this solution. It is, in fact, basic. So this is example problem number 2. Calculate the hydrogen ion concentration of a base that has a pOH of 4.50. So we're asked to find the hydrogen ion concentration, and we're given the pOH. So this is a 2-step problem. And again, we could go one of 2 ways, but I always prefer to use the equation pH plus pOH equals 14 because adding and subtracting is just a lot easier to me than trying to multiply or divide. So by that rationale, we're going to use the pOH to calculate the pH. So we are going to rearrange this equation right here. And it's going to give us the pH is equal to 14 minus pOH. Then we're going to sub in, the pOH to give 9.50. So 14 minus 4.50 equals 9.50. We're going to find the antilog of this. So this is the pH, and we want to find the hydrogen ion concentration from the pH. So by finding the antilog of this, that means we're going to take 10 to the negative pH, which is 10 to the negative 9.50, put that in our calculators, and you're going to get 3.2 times 10 to the negative 10 moles per liter of hydrogen ions. So this is checkpoint number 2. What I want you to do is grab that piece of paper and complete these 2 problems, and I want you to turn these in per your instructor's directions. Keep in mind, I do have a little hint there for finding the molarity of a solution of a particular substance. So, what is the pH of a 0.10 molar solution of KOH? And then question number 2, find the molarity of hydroxide ions in a solution that has a pH of 15.2. Now, when I originally found the template for these slides, because I didn't want to use the same templates over and over again, I wasn't really looking at the content, but it was a slide show on hygiene, and then I got to this particular slide, and I just couldn't take it out because of the current situation of things. So I kept it in here as a reminder to wash your hands to help stop the spread of the virus. That concludes this lesson on pH and pOH. Please let your professor know if you have any questions.